Thank you very much for joining in. My name is Vinayak and I'm a front-end engineer. In this video, I'm going to talk about closure. This is a very important concept in JavaScript, and as my first video, I just wanted to touch upon it and maybe help others, because I think I can explain it. So let's start. So I have a stack blades window open. In this I have index.js file opened. I have a bunch of functions that I have created just to quickly give you a brief about how the JavaScript functions. I know many of you know, but I just wanted to give you a context and then provide the final explanation about closure. So I will sometime might be stating the obvious, so please do not mind it. Just hang in there, and at the end I will connect the dots. Now in this file I am creating a variable. Now when this variable is created, it is stored inside a global execution context. Now what is global execution context? As soon as you open index.js, there is this execution entity that you can think of that takes over and kind of manages where the variable will be stored and where how the execution will carry on. So there is something called a global execution context, and that is an entity. You can think of it as an entity that takes over as soon as you open index.js and try to execute it. So okay, with that out of the way, let's move forward. Now I'm creating bunch of variables here. All these things are variable. It can be different. What makes a variable different? The thing that we store in it, right? If I store a string, okay, it has a different behavior. If I store a function, it has a different variable. So that's what we have to keep in mind. So I will be referring these variables as labels, so please bear with me. So first label that I have, that is named as var1, that has a value. So this is label, this is value, this is label, this is value. Okay, label 1 var1 has a string hello world. Label 2 function with parameter and return value has a function stored in it. So just to give you a brief, functions are stored in heap, and that is a different kind of memory, and the address to that function will be stored in this label. Okay, so in here this label stored hello world exactly as it is. Here something different has an address. Okay, all right, so the address can look like 123. I don't know how these addresses are calculated, but this can be some sort of random number, bunch of random numbers. Okay, another label that has a function in it is function with no parameters but a return value. All right, and the declaration goes on. All these labels are stored in global execution context. Why? Because so far we only know, this index.js knows only about global execution context until this statement. Okay, why I say so, I will explain it. Okay, so far we have these these variables stored in global execution context. Now we hit this statement. It says go ahead and create another label, that is rv. We go ahead and we are very obedient, so I will just go ahead and create this rv. Now the next thing is an assignment to a returned value, and I'm assuming that this is returning because only when we can assign something if it is returned. So this function, this here is invocation of a function which we have already created, and this is returning a value, so that's why we are storing it in here. So this RV will not get its value immediately. What happens is this RV will wait, because the thread which was responsible for executing all the statement line by line will move to this function, and another execution context will be created, and something called call stack will also be will also come into picture. That was always there, but that will become active because it will push this function. It will push this function at the top, and turns out there was nothing before, so that's why this function will be on top, and this execution context will be created. When this execution context will be created, this variable will also be created, because this is native, right? So this variable will also be created. What will be its value? Its value will be 2. Its value will be 2. var1 will also be created, and you get the gist, right? Where 1 will have v1 as its value. Okay, bunch of console.log statements, they do their job. Here return var1. JavaScript goes and it does not understand what is var1. It first checks var1. It does not understand. It asks its local execution context, do we have var1? Okay, turns out we do have, because we saved here. So yes, we have it. Okay, let's return its value. It will provide its value, and that value will be returned. So var1 will be returned, and that's what we will log it here. So that gets assigned here, so that var1, the value whatever it was, I think it was v1, right? v1, that gets returned, and then it will be here, saved here. As soon as we hit the return statement, we destroy the execution context. Now, interesting thing is, if you do anything after return statement, that will not be evaluated. JavaScript will simply ignore it. So you hit the return statement, you destroy the execution context. So now we don't have past val, like they cease to exist. Snap. Okay, we destroy it. What happens to call stack? The function also gets popped out. Okay, now we are again back to global execution context. We move forward. We do not have any statement to execute, so that's why nothing nothing on console, and nothing is happening actually. If we invoke another function, like we go ahead and do anything like this function will be evaluated, hello world will be printed, and like as soon as, so suppose we were here and we see this statement, another execution context. Okay, it gets finished. Okay, execution context done, dusted. What happens in the case of a function that has another function invoked inside it? Well, that execution context, so we will just go ahead and first invoke it. We will do it over here. So this function gets invoked. Okay, it has a var1 variable that gets created. So let's go ahead and do a quick try run. Okay, what am I drawing? I just wanted to be quick. Come on, man. Okay, here. So this execution context gets created. We name it, we give it a label, and we also create this division. so that we can, like, the execution environment will be this, the memory will be this, and that's why whenever we have this execution created, the thread will be over here. Now the first statement is var1. Okay, let's go ahead and create this variable var1. Okay, let's change it because I don't want to create confusion here. So let's say we have okay, I'm very bad with naming. What should we, so let's say v and printed v. Okay, so this is the label and the value is this, hello from outer function. Okay, I should be good at this, right? Hello from outer function, that is its value, the label is v. I should be more descriptive. VL, okay, let's see, value, and then here value. Okay, so this value was created, this label was created inside this execution context. Another label will be created, and that is for another function. Here, so I said earlier that label creation, okay, it does not make any difference. What we store inside it will make a difference. So this is a function that we are storing, so the behavior will be different, but you should always think of it as a label, no matter what. So value is a label, another function is a label. Again, this another function gets invoked. So here another function gets invoked, and that's why I am adding parenthesis. When this function gets invoked, the call stack which had this function right now, which had this function, will now push another function on top of it. So another function will be over here now on top of it, and the execution thread will move inside another function. So another execution, so that always means that you will have another execution context, and in another function we will have the similar separation, execution environment and the memory, the temporary memory where variables will be stored. Luckily we don't have any variable created, so we do not have any statement that that wants to create a variable, so we don't have any variable over here, but still we are reaching out to value which do not have which is not created inside this function. So how does it find it? Well, it will first check inside this memory, temporary memory. It will not find that, then it will move out and then will check this outer execution context memory. It will find it and it will print it. Please note that while it did not find it over here, but the outer execution context was still in the call stack, right? It was in the call stack, which meant that the execution context of the outer function was still alive, and that's why it was able to find value. Had it not been alive, it could not have found the value. So please keep in mind, I will connect the dots. Alright, so here we console log the value. It was able to find it in outer execution context. We also console.log running function. Okay, everybody is happy. another function gets over, we destroy the execution context. We also pop the function out. The thread moves again back to the function with another function declared and invoked execution context. Weird name. And it does not find any other statement over here. Had there been any any statement, it would have been evaluated, but there is none, so it also gets destroyed. The execution context gets destroyed and call stack also pops the function. Okay, everybody be ready for the ultimate showdown now. So you understand this pattern that we will have a function that will have a return statement. Return statement can have a value that can be string. In the coming example, we will see that return statement can also have a return value as a function, and that's where the concept of closure lies, because then we will see how variables are accessed and how they are reached. Okay, so okay, moving on. So we will create a function, outer func here. So it will be quite similar to this with some tweaks. So we will create an outer function. We will also create a variable, and that will be like count is equal to 0. We will create a function that will be in a, so you see the pattern is quite similar, right? We create a variable, we create a function. We create a variable, we will create a function. So this will be in a, and here I will reach out to console.log count. I will increment it, count plus 2 is equal okay, count plus plus, let's do it like this. Okay, and I should make it like reassignable. Alright, and I will return inner. Okay, what is the difference? Here I was creating a function that had a value in it. I also created a function inside it and invoked it. I'm not invoking it inside this outer one, but I'm returning it. So this function, when will be invoked, will return this inner function, and this inner function then can be called using the variable that we have used to kind of store the returned value. Okay, so that's what we will do. We will over here const return value rv is equal to outer function, and we will invoke it. Now this is a function, right? So this has reference to this function. Now since this is a function, we should invoke it. We do it. Fv is not defined. Where is fv? Okay, rv it should be, right? Okay. Now it prints out 1, which seems okay, because we like declared a variable, gave a value 0, we then incremented, and we like console.log it. Okay, seems fair. Let's see it in action. Then only we will see where the problem is in our understanding. Spoiler alert, that is not what is happening. It is not referring to this. Okay, now that I have your attention, let's see what happens. So as soon as this function is invoked, this outer one, an execution context is created. Okay, it will have 2 separate division. The first one for variable, the first one for execution environment, and the second one is for memory. Now here we create a variable that is called count. Okay, we go ahead and create that. We create count. we provide it a value that is 0. Okay, we do that. Alright, we provide it a value. We then now create inner. This is a variable, right? This is a label that we are going to create. We create inner. What does it store? It stores a function. Okay, let's store it as a function. Fn. Okay, now here this function, now in here it is not invoked, which means we will not go into another execution environment just like we did in this, because it was invoked. Here it is not invoked, it is returned. Now it goes ahead and checks the return statement and evaluates what is to be returned. It sees that inner is to be returned. It checks if we have access to inner. It goes ahead and checks, okay, yeah, we do have inner, something called inner in our local execution context, so we will return it. Okay, the value is fn. That gets returned and that gets stored over here. So this this function right here has access to this code. Forget about inner, this has access to this code. As soon as return statement is met, like hit, and we go ahead and destroy the execution context. So in our global context there is a variable called rv, and that has code, that has access to code, which is this. I'm not referring to inner, I'm just referring to this code. Okay, now I will just return it, I will put it over here and destroy this context. Gone, done, dusted. Okay, since this was a function, we invoke it. Alright, let's go ahead and create the execution context for rv. Here, as I mentioned, that this has access to this code. Now as soon as we go ahead and read the first statement, we see that this says count plus plus. Now where does this count lie? We don't have count over here. We don't have count in here as well, right? We don't have access to count. How does it evaluate that it is 1? That's a mystery. Well, this is not a mystery. Turns out, whenever you create a function inside a function, so let's go back, let's evaluate this function. Let's go back to this. When this function was invoked, there was an execution context that was created. Inside this context there were two variables, count and inner. Well, as it happens in JavaScript, whenever you create a function, this function will also have kind of a handbag. So think of it as a like, how do I mention it? So think of it as a school bag, or think of it as wallet. Come on, I should come up with something different. Okay, backpack. Think of it as a backpack that it holds. As soon as it is created, it will fill backpack with all the surrounding variable that has been created, and that is like in its environment, which is like this one, not this one. So it cannot go outside, its environment. It should stay inside its environment and then check for any variable that is created inside it. Okay, if it finds 1, If it finds one, it will just put it in inside a backpack. So which means now when this function will be returned, and I'm not talking about inner, I'm just talking about this here, this function. So when this function will be returned, it will carry with it the count and all the variables. So if there will be another variable called var, like value or something like that, it will also be like attached to it. So for its life cycle, it will have access to these values, and that is called closure. So basically these values are closed with this function. It will have a lifelong access to count, even though the execution environment was destroyed after the completion. Since it was returned, it had access to the count variable, because it was within its environment. It will have a lifelong access to count, and that's why we are able to do count plus plus here. And like if we do another, like rv, if I execute once, it will have 1. If I go ahead and do rv again, I execute it again, the count plus plus is incremented. So that means it has a persistent memory now. So this function has a persistent memory. Oh my god. So this can blow your mind. How can I have a function, in order to persist something, we use so many different technologies, but now here is a function that has a persistent memory. It knows where it kind of left and it resumes from there, right? That is awesome. And you will hear about generators, you will hear about so many like reducers. There are so many things. All these functions, they use closure, and that's awesome. So I hope you understood. There are so many cool things that you can do using closure. I can create a function that can only run once. So no matter how many times you go ahead and invoke it, it will only run once, and if you run it again, it will give you an error. So I can do that. I can also there's something called decorators in JavaScript. You can use the concept that you have learned here for creating decorators. So if you want more videos on JavaScript, please let me know in comment section, and I will surely prepare one for you. So thank you very much for watching. You've been very patient, and you stuck until